Get started? Yeah.
Yeah.
Okay. Get my background away from here. So it's my pleasure to welcome Daniel Vacanti to speak with us today. And maybe I'll just give a little bit of background about Daniel first. So Daniel has over 25 years experience working in the software industry. And I believe most of that time is working with lean and agile practices. A fun fact, maybe in 2007, he helped develop the Kanban method for knowledge work and managed the world's first implementation of Kanban projects that year. Since then, he's been conducting lean and agile training and coaching and consulting. In 2013, he founded the Actionable Agile, and it's a site, actionableagile.com, that I would highly recommend everybody to go to and to take a look at it. I think the tool and that you have in there and the demo of the tool is fantastic, Daniel. You've written 2 books, Actionable Agile Metrics for Predictability in 2015, and the more recent one, When Will It Be Done, in 2018. The first time, Daniel, I know that Dee was saying I was one of your biggest fans, but the first time I came across your work, I believe, was something around 2014. It was a white paper called Actionable Metrics at Siemens Healthcare. And I know there's many people on the line here that I've shared that document with. That paper really did something to me. It changed the way I thought. So thank you for that. Like, anytime you can change people's thought patterns, I think it's a good thing. It really opened my eyes and provided a fresh kind of perspective on how I looked at metrics, and I've had that perspective ever since. It was also the first time that I came across Little's Law and the relationship there with cycle time, throughput, and WIP. So thank you again for that one. But before I have any kind of spoiler alerts on what you may be talking about today, I think I'll leave it at that and just like to say a very warm welcome, Daniel.
Thanks very much for that very kind introduction, Vince. No pressure, no, right? after that, but no, I'm glad to hear you enjoyed it, and hopefully other people have seen some of the things that I've done and enjoyed that. Yeah, I mean, today we were talking before the call. Today, what I'd like to do is, well, I do have a presentation I'd like to work through. These things always go better, I think, selfishly for me, but hopefully even better for you if we make it kind of interactive. So I will kind of be progressing through some slides, but I will be pausing from time to time, asking questions, inviting you to ask questions, even inviting you to participate, in a couple of situations. So as far as I'm concerned, the next hour is yours. So what I mean by that is, just please, as I'm going through this, if you do have a question, unmute yourself, interrupt me, ask it. If you're more comfortable, maybe putting the question in chat. Dee and Vince have promised to keep an eye on chat and interrupt me if they see something interesting going on there. So hopefully let's just have a little bit of fun for the next hour or so. Because I will be taking questions along the way, I don't know how much time there will be at the end for questions, but I'll try as much as possible to leave a little bit of time for discussion too. And I don't really have anything, I was just saying this too, I don't really have anything on after this. So if anybody wants to stay a few minutes late and chat, that's fine too. So let's jump right into it. Let's see if my see if my screen sharing works. There. Everybody see the screen okay? Yeah.
Yep.
Yeah. We're gonna be focused today. We're gonna be focused mostly on answering this question. When will it be done? We'll talk about really kind of the ramifications of that question here in just a bit. But I really do like to start this particular presentation anyway by making you a deal, and more specifically, playing a game called Let's Make a Deal. I don't know if anyone's ever seen the game show Let's Make a Deal, but it's one of the worst kept secrets in American game shows, is that all the best American game shows are actually created by Canadians. And so Let's Make a Deal is a game show that was created by this gentleman here. He kind of looks Canadian, don't you think? I don't know, he looks Canadian to me. His name's Monte Hall. And in the 60s, Monte Hall created this game show called Let's Make a Deal. And like I said, if you've ever seen it, it looks something like this. And the reason there was a reboot recently, Monte Hall has since retired, and anyway, it's been rebooted with the gentleman called Wayne Brady. And whenever you watch, if you're in America, I don't know if Ireland has its own version of Let's Make a Deal, but if you ever see it, this is what the audience looks like. And the reason you see everybody dressed in these crazy costumes is the way the game show works is Monte Hall or Wayne Brady or whomever will walk the audience and randomly pick people out to play certain games. And so that's why they dress up in these kind of crazy getups to get Wayne Brady's attention to say, hey, I want to play this game. So let's do that. I want to play one of these games because one of the games is, Monte Hall will draw somebody from the audience, like I said, at random, and he will direct the contestants' attention to the stage. And on the stage, there will be 3 closed doors. Behind one of those closed doors is a brand new car. Behind each of the other 2 closed doors is a goat. Objective of the game is very simple. Pick the door with a brand new car, you win the car. I always get asked, if you pick the door with a goat, do you get to keep the goat? And I actually went look this up. For number 1, I'm not sure why so many people ask that question, but number 2, went and looked it up, and unfortunately, no, you don't get to keep the goat. Either you pick the car and you get the car, or you go home with nothing. So let's do this. Let's take a look at what this might look like. Let me switch screens here for just a second. So here's an example of the game that I'm talking about. So you can see we got 3 closed doors. Behind one of these closed doors is a car. Now, I know a lot of you have probably seen this example before. So if you have seen this example before, please, 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 I beg of you, please don't ruin it for those of you who have not seen it. But what I'd like is for somebody who has never seen this example before, has no idea what I'm talking about, Monte Hall, Let's Make a Deal. If I could get one of those people to volunteer to play this game with me, and I promise nothing bad's going to happen to you. Nothing bad. In fact, like I said, I'm hoping we'll have a little fun with it. So is there a volunteer out there who has never seen this Monte Hall game, this Let's Make a Deal game, who would like to play along with me? Anyone? Has everybody seen this example?
There's a thumbs up there from somebody in the.
I don't.
You might need to shout your name out.
Amy O'Callaghan.
Hi there.
So Amy, did I hear right, Amy?
Yeah, that's it.
Okay, thank you very much, Amy. Thanks very much for volunteering. Hopefully you understand the rules of the game. Very, very, very simple. Doors 1, 2, and 3. Behind one of those doors is a brand new car. Amy, can you tell me which one of these doors do you think has the brand new car?
I'm going to try number 3.
Number 3, excellent. Okay, so Amy has chosen door number 3. Now, what I'm going to do is, in a second here, I'm going to click on door number 3. And when I do, what you will see is either door number 1 or door number 2 is going to open, revealing where one of the goats is. So most dangerous words in the English language are watch this, but I'm going to click on door number 3, and okay, there you go. You can see door number 2 is opened, revealing where one of the goats is. Okay, Amy. So now this is where the Let's Make a Deal part of Let's Make a Deal comes in. Given the fact that you just chose door number 3, and given the fact that I just opened door number 2 and showed you where one of the goats is, I am going to give you this one-time only option to, if you want to, right? You do not have to, but if you want to, I'm going to give you the option to change your answer from door number 3 to door number 1. And so the choice is yours. Either stick with door number 3 or switch over to door number 1. Amy, what would you like to do?
I'm going to stick with number 3, please.
You're going to stick with number 3. Perfect. Wonderful. Would you mind for our TV viewers at home, maybe talking through, if you're comfortable, kind of talking through what your thought process is in terms of sticking with door number 3, if that's okay?
I think it's very much a game of luck, and yeah, 3 was just more confident with 3 from the onset.
Okay. If I can, which is perfect. That's kind of what I was expecting to hear. If I can maybe restate that back to you, and you tell me if I'm kind of on the right track here. When you're thinking, as you said, which by the way, I love the term, this is a game of luck, which it is. You're thinking when all 3 doors were closed I had a roughly equal chance of being right. So it's just, I'm just gonna pick one. I pick a number that I'm comfortable with. So I picked door number 3. Then when I revealed door number 2, you probably sat there and thought, well, there's not really any much better information. It still looks like I kind of have an equal chance. It's either door number 1 or door number 3. I kind of still have an equal chance of winning. So I think I'd probably be more upset if I switched to door number 1 and was wrong than if I stuck with door number 3. Right? Is that kind of, did I put way too many words in your mouth there? But like I said, I love the language you're using, which is luck, and that's exactly why. Oh, by the way, maybe I should, Amy, if you don't mind, I'm actually not going to give you the answer right now. I'm going to come back to you a little bit later in the talk, and we're going to resume this. Because here's the deal, not just Amy, but everybody else. If I gave you the answer right now, everybody would just tune off and go finish their lunch or whatever. So I got to keep you interested somehow. So yes, we are going to come back to this in a little bit. But the reason that I like to start with this is because, as Amy said, this is a game of luck. What I essentially asked her to do was to make a prediction. I asked her to kind of forecast. Hey, where is that car? And the second that we're asked to make a forecast in the presence of uncertainty, because we got a ton of uncertainty here, the correct thing to do is to start thinking probabilistically. Think about it exactly. Think about it as a game of chance. That's totally how you are supposed to think about it. That's the good news. Thinking probabilistically about the problem. The bad news is that in general, humans, we are very, 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 very bad at thinking probabilistically. It's just not in our nature to do it. It's not very intuitive to us. In fact, it's very, very unintuitive to us. So that's the bad news. But there's some things that we can do to kind of help us, understand probability and start thinking probabilistically. So, Amy, if you don't mind, I am going to come back to you probably about halfway through the presentation, and so don't go anywhere, don't run away, and we'll come back. So the other, I guess, before I move on, the other thing I would like to mention is, again, those of you who haven't seen this example before, just make a mental note. If you were Amy, what would you do? Would you switch or would you not switch? And maybe you'll have a chance to participate a little bit later as well. Okay. Enough of let's make a deal. One other thing, there wasn't a last time, but so I don't know if you knew this, you had homework before this talk, but you have a chance to redeem yourself here. This is what I would like to know. Here's my next question is, what does a 19th century Yorkshire cotton industrialist have to do with a Manhattan Project? So anybody with Google at the ready? Again, I'll come back to this a little bit later, but I want to know, what does a 19th century Yorkshire cotton industrialist have to do with a Manhattan Project? Right? Okay. We were just talking about forecasting, and I know it's a bit cliched. It's very cliched actually, but it's, I suppose, especially in Ireland, or maybe not in Ireland. But what is one forecast that you come across every day of your life that you maybe check even multiple times a day? What's one forecast?
The weather.
The weather, exactly right. Yeah. And I don't know if everybody heard, I live in South Florida. And so there's a particular type of weather forecasting that I am especially interested in, and that's hurricane forecasting. So we're going to talk specifically about that. Everybody probably knows, you're all familiar with the geography, of the Earth. This area of the Southern Atlantic right here is renowned for its storm activity. And, in the summer months, storms that are generated here generally track to the west and to the north. And as they track west, they get bigger and bigger and bigger and turn into these much bigger storms that are called hurricanes. So if a storm forms here and it tracks to the west and to the north, where is it most likely to hit? Or where is it, I shouldn't say most likely, where is it very likely to hit? Anything that's here?
Caribbean and Florida.
Yeah. I mean, yeah, we don't, because it's America. We don't care about the rest of the world. So I'm only going to talk about the United States. But it's very likely to hit the eastern seaboard of the U.S. So the United States, as you can imagine, has a vested interest in tracking these storms, when they develop. Now, just for reference, that's where Dan lives. And this is my very first hurricane season in Florida. This was, I believe it was Hurricane Michael. Had just moved down to Florida. Hurricane Michael hits. Now, Michael never made landfall in Florida. It stayed about 100 miles offshore, but you can see that we still had hurricane force winds that were knocking down trees, knocking down fences, power outages all over the place. And you can imagine that got my attention. And so I wanted to learn a little bit more about this forecasting stuff, because this is, just even a slight ramification, of a storm hitting. So, but I don't want to talk about Michael. When we talk about hurricane forecasting, I want to talk about something else, a different storm. And this particular storm formed on October 22nd, 2012 in the Southern Caribbean. I don't know how many of you are familiar with this, but the United States has a government agency called the National Hurricane Center, NHC, the National Hurricane Center. And whenever these storms form, the National Hurricane Center puts out these types of advisories. And you can see this is so early on in its development, in the storm's development, that it didn't even have a name yet. It's called Tropical Depression 18. You can see Monday, October 22nd, Tropical Depression 18. Everybody knows we name our storms. We name every storm now, whether it's a hurricane. It's like any storm that blows through. It's it gets a name. But this is so early, didn't even have a name yet. Tropical Depression 18. This particular storm grew to become the largest hurricane ever seen in the Atlantic, largest ever, or as measured by diameter, right? Just sheer size, sheer volume. Does anybody know its name? The largest hurricane ever seen. It's still, by diameter, it's still the largest hurricane ever. Anybody know its name?
Andrew?
No, it's not. Andrew's a good guess. It's not Andrew.
Katrina?
Katrina's another good guess. It's not Katrina. This is why I asked this question, because most people outside of the U.S. have never heard of this one.
It's not Floyd.
Sandy?
Right.
It is. Yeah, it's Hurricane Sandy. Hurricane Sandy was actually so big they called it Superstorm Sandy. I don't know if anybody remembers that, Hurricane Sandy. But as I mentioned before, Hurricane Sandy was the largest hurricane ever. At the time, it was the second costliest in U.S. history, second only to Katrina, which I think is why most people guess Katrina, because Katrina did a ton of damage. Sandy was actually bigger, but didn't do as much damage. And it affected 24 states. Of course, we can't forget our friends north of the border, 24 states and parts of Canada, with New York, New Jersey, and Pennsylvania suffering the most damage. 24 states, that's pretty much half of the US in one way or another was affected by Sandy. When a hurricane hits, a normal hurricane hits, 2, 3, maybe 4 states are affected. This hit 24 states. This thing was a monster. And the question is, would you have predicted any of that just by looking at this picture, that very first hurricane advisory or storm advisory that the National Hurricane Center put out? Of course, that's a rhetorical question. No, there's no way you could have predicted that. But there's one other thing that I want to mention about Sandy before moving on. And that's this. There's surprisingly little loss of life. Now, I don't mean to trivialize any loss of life. Obviously, any time there are casualties like that, it's a tragedy. But with all those statistics that I just put up, with that long list of statistics that I put up, you would expect a corresponding long casualty list, and that just did not happen with Sandy. And that got me thinking that there's something that the National Hurricane Center knows about forecasting, maybe that we in the agile world, that maybe we don't. Are there some things that we can learn from how the National Hurricane Center does things, such that we can prepare people as much as possible? So let's talk about this picture first. Can anybody tell me, just from a visualization perspective, this advisory is designed in a way to draw your eye, to draw your attention to like the single prominent feature of this advisory? Can anybody tell me, just like, this is an easy question. I hope this is an easy question. What's the dominant feature of this advisory? What are you supposed to be looking at?
The white shape.
The white cone. Exactly right. That white cone. That's exactly what you're supposed to be looking at. Can anybody tell me, does anybody happen to know what does that cone signify? And I'm going to be fairly pedantic about this, but what exactly does that cone signify?
Tripled in size in 4 days.
It's actually not size.
Probability it'll be in a certain
Probability
location.
of
Go ahead. Probability of
trajectory.
trajectory of, like I said, I'm going to be very pedantic.
The eye of the storm.
Exactly, the center, right?
The center.
Yeah, most people think, you know, as was suggested, that this kind of represents the size of the storm as it's moving forward. It actually doesn't represent that. This cone represents the, you know, a sum, if you will, of the paths, the potential paths of the storm center. So the storm can go, you know, anywhere from up this west edge to this east edge right here, and anywhere in between. There is, if anyone has seen this advisory before, I don't know if you've ever noticed, at the top of this chart, there is some text. And I'm going to blow it up for you. And it actually explains what this cone is about. It says, note, the cone contains the probable, that's my emphasis, by the way, the cone contains the probable path of the storm center, but does not show the size of the storm. Hazardous conditions can occur outside the cone. That's what that picture I just showed you with Michael, that's exactly what happened with us, right? The center of the storm was 100 miles away, but we had hurricane conditions well outside of that storm center. So probable, right? What do you think when the National Hurricane Center says the word probable? What do you think they mean? Now, keep in mind, this is literally life and death, right? If they get this right or wrong, you know, it can have huge consequences. So what do you think when they say probable, what do you think they mean?
The statistical chances it may occur or not.
Great. And if we had to put a number on that chance, what do you think? What number comes to mind if we say the word probable?
The Gaussian distribution.
More than 50%.
More than 50%, which is good. But remember, we're talking about life and death here. So I mean, are we wanting to do a forecast based on a 50% probability? Do you think?
Is it that they know it won't be outside that range?
So you're saying it's 100% that it will be within the cone?
Yeah.
Is that what you're saying?
Yeah.
No, I wish. No, we're going to talk about that. And we're going to talk about that exact point here in just a second, though. It's not 100%. It's not. It's. So I'll give you a hint. It's greater than 50 and less than 100.
80%.
80%.
85.
I think
Yeah.
it is unpredictable, right?
I mean, I have to tell you, when I first saw this, like I said, and I live in Florida, and I say, hey, this is the probable path of the storm center, and we're talking about life and death. The number that came to mind for me when I first read this was like 90-95%. I'm like, we are pretty darn sure that the storm is going to go here. This is one of the reasons, by the way, why I love the National Hurricane Centers, because they're very, very transparent about how they do their forecasting. And you can go to their website and you can read all kinds of information about their methodology and their approach and things like that. And if you do that, I'm a geek, I'm a nerd, I've done this, right? If you go do that, you'll find out that cone actually represents a 60 to 70% chance of the storm center being located within it. 60 to 70%. I have to say, I was pretty disappointed by that when I first read it. I was like 60 to 70%, because I was thinking like maybe some of the rest of you is like, I'm like, why aren't we at 100%, or at least very, very close to 100? But why not exactly 100%? Why can't they tell me with 100% certainty where this storm is going to go? Why does that cone not represent 100%?
Too many variables to predict.
Too many variables, exactly right. What are some of those variables? What are some of the things that change over time?
The wind, the sea, temperatures.
The wind speed and direction, yeah, the sea temperature, whether the storm interacts with land or not, whether there are other storms in the area, et cetera, et cetera. So there's this long list of variables that change over time that there's no possible way that they could give us 100%. If we demanded 100% forecast, what would that cone look like?
Huge.
It'd essentially be Earth. You'd have to you just draw a circle around the globe, and there's your 100%, right? If that, in other words, it'd be the cone would be way too big to be useful or meaningful in any significant way. This is kind of the crux of the issue, right? Whether forecasting is uncertain, that's pretty obvious. Whether forecasting is uncertain, so therefore we can't think deterministically. When I say deterministically, I mean throw 100% out the window. 100% does not exist. Whenever uncertainty is present, 100% is gone, right? So what that means is we need to start thinking probabilistically, not deterministically, thinking probabilistically. But remember, I said humans aren't very good at thinking probabilistically. And I'll be honest with you, I'm not really even sure what it means to think probabilistically. And this is probably the best definition that I've come across around what does it mean to think probabilistically. And that means it means acknowledging that there is more than one possible future outcome. There are many possible futures, each of which has a chance of happening, a specific chance of happening. For me, this is the best way to think probabilistically. And this is exactly what the National Hurricane Center does. This is exactly how they think about the world. A lot of you probably know this. They run different models, they run different simulations. And this picture is an example of that. Each one of these lines, this was for Sandy, by the way. Each one of these lines represents one run of one of their models. Each one of these lines represents a possible path of Sandy, right? And you can kind of see how they're able to draw a cone based around, say, 60% of these, of these simulations, but each one of these is a possible future, and we don't know exactly which one is, it's going to hit. Here's another, good example of that. By the way, these are called spaghetti models, in case anyone's, or spaghetti plots, in case anyone's, wondering. But that's what those things are. So more than one possible future outcome. Given that, was this the only forecast the National Hurricane Center made? Did they say, okay, we got this tropical depression 18, it's in the Southern Atlantic, here you go, here's our forecast, see you later, and they just walk away? Is that how it goes?
They keep
That wasn't
updating it.
Yeah, I was going to say that wasn't meant to be rhetorical, but okay, we can take it as rhetorical. Yeah, and the answer is no. I mean, the National Hurricane Center, they keep updating their forecast as they get more information. So this is the next advisory that they put out. This is now exactly 24 hours later. If you look down here, at the bottom, we now have a name for Sandy. It's called Tropical Storm Sandy. It's now Tuesday, October 23rd. Like I said, 24 hours later, and this is the forecast that the National Hurricane Center put out. Now, imagine if they did that. Imagine if they said, okay, you know what? All right, we've got our storm. It's got a name. It's Tropical Storm Sandy. Here's the forecast. And they just drop the mic and walk off the stage. It's like, here you go. This is it. Have a good time. How would you feel? This is not a rhetorical question right now. How would you feel right now if you lived in New York, New Jersey, or Pennsylvania? Remember I said those are the three states that got hit the hardest. How would you feel right now if you lived there looking at this forecast?
I wouldn't be concerned.
You'd probably be like, maybe go to the beach this weekend, maybe have some friends over for a barbecue. We're going to party. This thing. First of all, it's going to be a tropical storm, and it's going to tail off into the Atlantic. So who cares? This is going to be great. 1 week later, this is what Sandy looked like. Can anybody even see New York, New Jersey, or Pennsylvania here? I mean, that's pretty impressive. So this, what happens is, the National Hurricane Center is constantly updating their forecasts as they get new information. New information is coming in, all the time. They have the Hurricane Hunter planes that they send into the storms. They have weather buoys that are gathering water temperature. They're able to know, like I said, whether the storm, interacted with land or not. So as this flood of information comes in, they take this new information and they update their forecast, and they update it, every few hours or so. Those forecasts are fairly continually updated. The next slide I want to show you is probably my favorite slide of the whole presentation, because it's a time lapse of all those forecasts. And you can see here, I think this is, it's pretty cool. You can see here, it looks like it's going to go off into the Atlantic, and then it takes that sharp left turn and just slams New York. You see that? But this is what I'm talking about. When I talk about this constant updating of the forecast as they get new information. So the final thing, there's one final dimension to this picture that we briefly touched on, but not really. We need to say a little bit more. How far in advance, how far out are they making their forecast here? Can anybody see?
It looks like 4 days.
4 days, yeah. Somewhere 3-4 days, somewhere in there. Well, 3 or 4 days. Why not 3 or 4 weeks? Why not 3 or 4 months? Why can't they tell me before hurricane season starts, what are all the hurricanes that are going to happen and exactly where they're going to go? Right? Again, what would that cone look like if I needed to know 3 or 4 months out where the storm is going to strike?
It'd be all over
Again,
the
way
States and the
bigger.
Atlantic.
It'd be Earth again, right? Just draw that circle around the globe and be done. So this, there's some basic principles of forecasting. Hopefully everybody's kind of getting the point here. There's some basic principles of forecasting that the National Hurricane Center understands very, very well, that maybe we in Agile don't understand very, very well. Number one, first and foremost, think probabilistically and not deterministically. Whenever uncertainty is involved, a probabilistic approach is demanded, is required. Number two, update your forecasts as you get more information. This is something that I call continuous or continual forecasting. Choose your favorite word there, but continuous forecasting. It's not like, we go into a planning session and coming out of our planning session, we've got the plan. It's like, hey, we got the plan. It's a plan. We got to work the plan because it's the plan, right? No, you get to change your mind as you get new information. And then the last one is shorter term forecasts are better. Generally, shorter term forecasts are better than longer term ones. I would argue this is the whole reason that Scrum exists. Scrum as a framework exists. Because I don't know if everybody remembers back in the waterfall days, the good old days of waterfall, where we had planning horizons of 12 months, 18 months, 24 months, whatever that was. And Scrum came along, and one of the things that Scrum said is, given complex product development, the best that we could ever possibly hope for would be to plan 1 month out. And usually we need to be much, much shorter than that. So, favor shorter term forecasts, over long-term ones. So like I said, how do we apply these principles to our work? Okay, that's great for weather forecasting, but how do we apply these principles to our work? Well, there's one thing that we need to consider, like from a customer's perspective. Let's think about this from a customer's perspective. From a customer's perspective, what forecasts are they interested in? Specifically, when a customer hands us a piece of work, what's the very first question that our customers are going to ask us once we start on that work for them?
And will it be delivered?
When will it be done? That's that. And when will it be done is a forecast. They're asking you to make a forecast. Now, I hate to tell you this, and you already know this, but there's a lot of bad news around when will it be done. When they ask you when will it be done, they're actually they're expecting a very specific form of the answer to that question. What is the answer they're looking for? What's the form of the answer that they're looking for?
A date.
They're looking for a date or a number of days. Right? The answer can't be, 16 story points. That cannot be the answer. That's not what our customers want to hear. They want a date or a number of days. It's even worse than that. Right? This is my favorite time of year to use this example. Because let's say it's December 1st. Let's say it's December 1st in Ireland. And we started working on something for our customers, and we say, hey, okay, this thing is going to be done in 30 days. Okay, December 1st, it's going to be done in 30 days. When is our customer expecting that item to be finished?
31st.
Yeah, but before the end of the year, right? So probably December 30th, December 31st, that's when they're expecting it to be finished, right? They think about the world in terms of elapsed time. Your customers aren't sitting there thinking, well, you know, Christmas holidays are coming up and nobody really works over the Christmas holidays. And then we get into the New Year's holidays and nobody works over New Year's either. And there are a bunch of weekends in there. So they say 30 days. What they really mean is middle of January. No, your customers don't think that way. Your customers think in terms of calendar time, in terms of elapsed time. Like I said, you know, story points velocity cannot be the answer to that question. Predictability, therefore, from a customer's perspective, predictability is the accuracy to which we can answer when will it be done, using our language of the customers. Right. So how do we actually answer that? Remember, we need to think probabilistically and not deterministically. What do we think? You know, remember I said thinking probabilistically is acknowledging there's more than one possible future outcome. So let's put this into practice as a real world example. Let's say that we've started a project and we've completed 12 stories in 1 week. Okay? We know that we have, of course we know this. We know that we have 120 stories left to complete in our backlog. Traditionally, if we were to take like a traditional project management approach, given this data, given this situation, when would we communicate as a traditional project manager? When would we usually communicate when that project would be finished? What would we say? What's the answer we would give?
10 weeks.
10 weeks. Yeah, we'd say we got 120 stories. We're doing 12 stories a week. This project will be done in 10 weeks. There are at least 2 problems with that answer, that 10 weeks problems. Actually, technically 3. The biggest is whether you knew it or not, that 10 weeks is you've actually computed an average. We're assuming that 12 weeks is average and that every week is going to be is going to perform on average. But the second that we start communicating something in terms of an average, we bring into play 2 big problems. First and foremost is this idea called the flaw of averages. This is your second bit, maybe it's your third bit of homework. I can't remember how much homework I've given you. Hopefully somebody's keeping track of all the homework that I've given you. If you were to read one book on forecasting, other than the 2 best books written by the world's best author on this subject, which we'll talk about later. But if you were to read a book on forecasting, this would be the book that I would have you read. And you really only have to read the first half. The first half is all the good bits. The second half is kind of case studies and things like that. So it's The Flaw of Averages by Dr. Sam Savage. But if I can boil this book down into one statement, it's this. And I believe Dr. Sam Savage says this in the book. It's that plans based on average fail on average. Right? Plans based on average fail on average. They also succeed on average, but they fail on average. Generally speaking, average means around 50%. It doesn't have to, by the way, and that's one of the flaw of averages, but we're essentially flipping a coin. If you're to make a forecast based on, on flipping a coin, do you think your customers would be happy about that? Probably not. There's another problem though with the 10-week answer. When our customer says, "Hey, when's this project going to be done?" and we say 10 weeks, in their minds, what's your customer thinking about that 10-week answer? What are they thinking? If they had to put a certainty on that 10-week answer, what certainty would they ascribe to 10 weeks? What confidence?
100%.
100%, right? Hey, when's this project gonna be done? 10 weeks? On our customer's mind, they're thinking with 100% certainty, this thing's going to be done in 10 weeks. So those are kind of the 2 big problems with the averages is, we have the flaw of averages, but then also we have not communicated risk to our customers. We need a way of communicating risk. Remember, the National Hurricane Center did this for us. When they communicated a forecast, look what they did. They said 2 things in their forecast. Number 1, here is the range of possible outcomes. This cone represents the range of the possible paths of the storm center. That's the first part of the forecast. The second part of the forecast is, okay, now that we've given you this range of possible outcomes, here's our confidence that this storm is gonna go in this area. So we have a 60 to 70% chance that the storm is going to happen in this, in that part. Right? And so any forecast that you give, whenever we're talking about predicting the future, any forecast you give should contain two parts: a range and a probability, a range of possible outcomes, and the probability associated with that range, happening. Okay, so if I'm telling you that a forecast should contain two parts, a range of possible outcomes and a probability associated with that range, what should be your next question to me? So you have to do forecasts this way. What are you going to ask me?
How do we calculate those?
How do you get it? Right? That would be your question to me. But unfortunately, no, this is the question that you should be asking. What does the 19th century Yorkshire cotton industrialist have to do with the Manhattan Project? Did anybody go look this up? Anybody have an answer for me? No answers? Nobody?
I quickly
Nobody?
Googled it. Said something about nuclear weapons or something.
Well, yeah, the Manhattan Project. The Manhattan Project was, yes, when the U.S. developed the project for developing nuclear weapons for World War II.
Past the first line on Wikipedia.
Yeah. The answer, of course. Sorry, so somebody said something?
Is it something to do with Carnegie?
No, close. Anytime you guess a Scottish person, that's usually a good guess, but no, it's not. It's not Carnegie. The answer, of course, is Monte Carlo. Monte Carlo, yes, of course, Monte Carlo. We could talk about that later. Why the answer is Monte Carlo. But if you ask me, Dan, how do I come up with a range and a probability for my forecasts? One of the best things that we can do is something called a Monte Carlo simulation, right? And this is where we go from Monty Hall to Monte Carlo. Amy, are you still with me? Hopefully you're still with me. Hopefully I haven't.
I'm still here.
Okay, good. You're not sleeping. That's always good news. When last we left Amy, going back to our Monty Hall game, she had picked door number 3, and I showed her door number 2, and I said, "Hey, you can change your answer if you want to." She said, "No, I want to stick with door number 3." Amy, I'm a little bit of a liar. I said I was only going to give you one opportunity to change your answer. I'm a nice guy, feeling fairly generous today. If I'm going to give you one other chance, if you want to, only if you want to change your answer. So do you want to change, or you want to stick with door number 3?
I'm going to stick with 3.
Okay, good. So I'm going to click on door number 3 here in just a second. But before I do that, let's do this. Let's have a little fun. Everybody in the chat window, if you can bring up chat in Zoom, and don't hit enter yet. Just do not hit enter yet. And what I'd like you to do is in the chat window in Zoom, type in the word switch if you think she should switch, or don't switch if you think she shouldn't switch. But remember, don't hit enter yet. So you're just typing in switch or don't switch. Once you have it typed in the window, then I'm going to count it down, and we're all going to hit enter all at the same time. Okay. Everybody got that? Everybody got their words typed into chat? Okay, here we go. 3, 2, 1, enter. Don't switch on. Yeah, this is pretty much what I expected. Everybody sees, just very, very unscientifically, I'm looking at kind of 50-50 don't switch. Maybe a little bit more is on the don't switch, but essentially 50-50. What's one way that we could figure out what the best strategy is here? Before I reveal the answer, what's one way that we could figure this out?
Monte Carlo simulation.
What in layperson's terms, what is Monte Carlo simulation? I mean, like for this particular example, how would we run a Monte Carlo simulation on this?
Just run it over and over again.
Yeah, exactly. You just try it over and over and over again, hundreds or thousands or tens of thousands of times. Just play this game over and over and over again and track the results. When I switched, how many times did I win? When I didn't switch, how many times did I win? And if you play it enough times, the exact probability of switching versus not switching will reveal itself. And that's exactly what this website does. It tracks people who switch versus not switched. And so we can see. So Amy, I'm going to click on door number 3 here, and Amy actually wins the car, right? But you can see down here, technically, Amy just got lucky. Remember, we did say this is a game of chance. For those of us, because Amy didn't switch. And for the people who didn't switch, you only have about a 30, it's really more about 33%. You have about a 33% chance. And for those people who switch, you have a 67% chance. Now remember, and this is really one of the biggest problems with probability, 33 is not zero, right? Amy still, even though it was technically a suboptimal strategy to not switch, that doesn't mean that Amy never wins the car. 33 is not zero. 33% of the time, she will win the car, right? It's just over the long term, the much better strategy by about 2 to 1 is to actually switch. Now, the math behind this and the probability behind this is well beyond the scope of this presentation. So I'm not going to go too deep into that. But that's really kind of rather the point. You don't need to understand the math. You don't really need to understand why this works the way it does, is because when you run the Monte Carlo simulation, the Monte Carlo simulation will tell you the probability. And this is really where Monte Carlo comes onto its own. If a problem is too complex to figure out, to calculate a probability, if you don't even know how to calculate the probability, right? In all these situations, one of the best things we can do is to run, a Monte Carlo simulation. So, congratulations, Amy. I don't know. Talk to Vince or Dee about what prize you win. I think Vince has it, has it already bought for you. So congratulations and thanks for playing. But hopefully everybody understands this is all Monte Carlo simulation is you try something over and over and over and over again, and track the results to get a probability. Now I don't have enough time to get into this too deep, but how this might work, in the real world, quote unquote, in the real world. And of course, this is taking forever, is, you can use a tool to say, I'm going to explain this very, very quickly. We're just not going to be able to talk about it. We can say, hey, look, let's take our historical throughput. Let's run our project over and over and over again. This histogram down here represents all the results associated with certain outcomes, just like we did in the National Hurricane example. And we can overlay those results on top of a calendar. So it's like, hey, given how we've been doing in the past, we're looking like kind of the middle of January for how this particular simulation is set up. We're looking, at about the middle of January, beginning to middle of January for when this project will be done. So if our customers come back to us and say, we absolutely have to have this thing done by December 1st, we can go in and we can say, well, you know what? There's a chance of that happening, but there's less than a 1% chance of December 1st happening. Is that a bet you're willing to make? Remember, as Amy said, this is a game of chance. Is that a bet that you're willing to make? Hopefully the answer is no. So if they want December 1st, this is where all the good project management stuff comes in. It's like, do we cut scope? Do we, God forbid, add people to the project? Do we even more, God forbid, start working overtime? Do we even more, God forbid, than that, work overtime and add people, right? But these are all options that are available to us that can reveal themselves through something like Monte Carlo simulation. Maybe I can come back some other time and we can do a deeper dive on Monte Carlo. I just apologize. We don't have time for that. Today. Like I said, we can maybe talk about it later too, if anybody wants to. So let me, I'll share my screen again, switch screens, get back to our presentation. So that's one thing. If you want to come up with a forecast that gives a range of possible outcomes and a probability associated with that range, one option available to you, it's not the only option, but one, I would argue the best option, is to do something like a Monte Carlo simulation. I'm going to do the same thing. We talked about that. This is principle number 2. Just because, so say you run your Monte Carlo simulation, you come up with your forecast and it spits out an answer. Here you go. Here's the answer. Just because you do that once doesn't mean you're done, right? Again, this drives me nuts about, certain agile frameworks out there that will remain nameless. Just because you've come up with a plan doesn't mean that that's the plan, right? As we're working our projects, as we're, doing our work, you're getting constant new information about, how fast we're going, about scope, about, customer feedback, about, defect rates, about, uncovered problems with architecture, whatever. There's dozens, if not hundreds of new pieces of information that you are getting. And as you get that new information, just like with the National Hurricane Center, you should take that information, incorporate it into your model, and rerun your forecast. You can rerun the Monte Carlo simulation. That's one of the biggest advantages of having a tool to do your Monte Carlo forecasting for you, is because you can start to approach something called continuous forecasting. I wish we had time for this, because this is a European audience. I can actually talk about proper football, not that stupid American stuff that they call football. That's not really football. But any sporting event, whether it's football, proper football, or American football, whether it's cricket, rugby, anything nowadays, if you're following these things live, you can generally find a website, as the game or as the match is being played, you can see, continually updated probabilities associated with that. This is a great example from the last World Cup, and you can see how the probabilities of Japan winning and Japan winning or Belgium winning changed dramatically over the course of the game because of certain events that happened during the game. Right? This is what I mean by continuous forecasting. I don't have time to get into this particular example right now. I'll give you the link. This is an InfoQ article. So Vince was nice enough to talk about the Siemens case study that we wrote up. So a few years later, I also wrote up a case study from a company called Ultimate Software. So if you just Google InfoQ Ultimate Kanban, you'll see this case study. But this is a case study of using Monte Carlo for continuous forecasting, kind of in the real world. Last principle: shorter term forecasts are better than longer term ones. And that's the thing with the National Hurricane Center. They're only forecasting 3 or 4 days out. Remember, same thing with kind of Scrum, that that's 2 weeks out, less than 30 days anyway, less than a month. If you get to a Kanban approach, that planning becomes even more, I would argue, just in time, which is, like I said, if you were to hold a gun to my head, I would say that that's probably the best approach anyway. Oh yeah, I don't have time for this. I wish I had time for this Monte Carlo case study. So we're just going to skip all that. Here's the deal: you can use to come up with our forecast. We can use something like a Monte Carlo simulation to take, our historical throughput to come up with a set of possible outcomes. We will then communicate that forecast in terms of a range and a probability. Remember, this has to be in the language of our customer. Customers need to understand, how long it's going to take in terms of what are my possible outcomes and what's the probability of me hitting the outcome. How much risk am I incurring? Update your forecast when you get more information. When possible, favor shorter term forecasts over longer term ones. By the way, that doesn't, why am I screwing this up? This doesn't mean that you can't do, that you cannot do long-term forecasting. Of course you can. And with Monte Carlo simulation, you very much can do long-term forecasting. It's just that when you do a long-term forecast, you can't be upset when that forecast needs to change because of principle number 2, right? Because we're doing continuous forecasting and we're getting new information, right? These basic principles of forecasting. If anybody's interested in a deeper dive in terms of how to apply something like Monte Carlo simulation to an agile situation, like I said, I would argue this is probably the absolute best book ever written by the world's best author, on this topic. When will it be done? If you want a deeper dive into the flow metrics that you need to track in order to be able to do something like Monte Carlo forecasting, that's this actionable agile metrics for predictability. As I mentioned before, there's the ultimate Kanban case study at InfoQ. I'll provide these slides as a PDF. So hopefully, these can be disseminated somewhere so you have these references. And we've got a few minutes. Are there 1 minute? Are there any questions?
Yes, I've raised my hand, Michael here. A very direct question. When we talk about velocity, story points, guessing, or whatever, we can provide cases where these approaches were wrong. Can you provide any case in which the probabilistic approach was ever wrong?
Was ever wrong? I mean, I think it's so my gut reaction to that is I think it's wrong a lot, but that's kind of the point is, so many times we come up with an initial forecast and then things change. Like I said, just like with Hurricane Sandy, that first forecast that the National Hurricane Center put out, 30 to 40% of the time, by their own admission, 30 to 40% of the time, that's wrong.
No, I wasn't sorry. My question was not if it didn't get the forecast right. The approach of moving away from assessing complexity and using story points and velocity and using probabilistic, if any case someone came back to you and demonstrated that the probabilistic was wrong and the deterministic was right.
Never say never, but whenever there's uncertainty involved, whenever there's even a shred of uncertainty, you have to do probabilistic. I would argue you have to do probabilistic. Has anyone demonstrated to me that probabilistic has been wrong ever? No. Likewise, no one has ever demonstrated that deterministic is right. So I'm not really sure.
Exactly my point.
Yeah, I'm not sure. I'm not really sure how to answer that. So, but I'm just saying that's the whole point of probability. It's the science of uncertainty.
Exactly. That was exactly my point. So
yeah.
It's possible to demonstrate that the deterministic is wrong and terribly wrong, and the first in the assumption that they're right, but it's not likely easy to demonstrate the probabilistic is wrong because by its nature. Thank you.
Yeah, I mean, and this is where it kind of crosses into more, for everybody out there, this is where it crosses into more art than science. So yes, you should be taking a probabilistic approach. How you come up with that model and how you're modeling, the complexity of your world, that's really going to be completely up to you based on your context. There's no one panacea for that, but I would always, again, not 100%. I would generally prescribe or suggest a probabilistic approach.
So Daniel,
yes.
Did you stick solely to the flow metrics as features, or did you widen it to say, some features that you may have got from, say, behaviors on a project when you were coming up with your forecasting?
Can you say a little bit more about that? I mean, I'm not sure.
So you have flow metrics, and you have you have the three, I suppose, primary metrics that you can use for determining forecast.
Yeah.
One goes up, one goes down, one stays flat. So permutations, combinations of that.
Mm-hmm.
Then you have what happens around that as well in relation to the projects that people are on and the behavior on the project.
Yep.
So did you just stick only to the flow metrics and what they might give you in terms of insight, or did you widen it?
Yeah, no, thank you for that. Thanks. To start out, my very strong recommendation is to stick with the flow metrics, if for no other reason that generally speaking, those flow metrics will encapsulate all of that different behavior that you're talking about.
Yeah.
So things like we've uncovered a ton of dependencies. Well, usually uncovering a ton of dependencies will make cycle times go up and throughput go down, right? It'll be reflected in the flow metrics. We've uncovered a deficiency in our architecture. Again, that will probably change our flow metrics. We've we got interrupted 1,000 times. We got interrupted 1,000 times because of all these other things that we're working on. Again, those will be reflected in the flow metrics. So that's why I think generally the flow metrics do a good job of encapsulating all of that other behavior that you're talking about. As you get really good at this, then yes, you can start playing around with, maybe adding different things to your model. But I'm a big believer in the KISS principle. And you very quickly reach, I think you very quickly reach a point of diminishing returns where adding complexity to your model really just doesn't buy you much. And in fact, potentially makes it worse. Does that help? Did I answer your question?
No, it does indeed, because I've often thought about if you start with the flow metrics and begin to widen your feature set out, there's all the the things in terms of behavior that go on in the project. But based on your answer, you're saying basically, the flow metrics are a good kind of a normalizer, if you like, of behavior patterns and smoothing that out. Have you ever considered or thought about if you do, say, just start with and stick with the flow metrics, if you're in an environment and they've expanded their capability to measure and get good information on, say, their pipelines, that you progressively include bits and pieces of the pipeline in terms of that feature set? Or
yeah. I mean, absolutely. Sorry to interrupt, but I mean, absolutely. Like I said, I can easily envision a world where there's meaningful information outside of the flow metrics that we should be incorporating into our forecast model. I mean, to me, that's not too hard to imagine. So yes, I don't want to discourage anybody from doing that. I guess that's my point. I don't want to discourage anybody from doing that. The only thing I would say is get good at the flow metrics first, and then you can judge for yourself whether that added complexity is really buying you anything. Right?
And last question, I don't monopolize the questions. When you did generate your probabilities, leaning towards better predictability and so on, was there any particular challenges in trying to sell that to, say, leadership or management?
Yes. That to me, that's probably the hardest question. That's probably the hardest problem to solve. And my normal answer to that is if I had a good answer to that question, I'd probably be sitting on the beach somewhere counting all my money. And I mean, although I love talking to all you good folk, I probably wouldn't be talking to you. No offense. I don't know that I have a real good. I haven't really cracked that nut yet, to be honest with you. Because even though, when you get right down to it, upper management and executives, generally speaking, they understand probability. They understand risk. Generally speaking, they understand risk. But for whatever reason, when it comes to agile development, they demand certainty. And that. I don't know that dichotomy, that cognitive dissonance, if you will, it's hard to get past. So my general approach is, because they understand risk, usually to frame the problem in terms of risk, like, hey, this is how much risk you're taking on, and frame the conversation that way. That's where I've had the most luck. But I do not, just in full transparency, I do not have a great answer to that question. I'm sorry.
And no, that's fine. That's perfect. And just a small tail to that then, having introduced the language around risk to hopefully resonate with the leadership level, have you gone back then and said, well, when we followed this in the past, 9 times out of 10, we've been pretty good. We've been nailed ahead, in fact, in terms of actually coming up with a good determinant of, yes, we're going to hit the deadline or whatever. Have you actually kind of completed the circle and say,
so yes, I mean, that's one of the biggest things is trying to measure the goodness of your model, if you will, the goodness of your forecast, because and I don't want to get political here at all, but if you remember the 2016 presidential election, where a certain candidate won, that only going into that election only had a 25% chance of winning, and remember the press came out, and because it was like Nate Silver was one of the guys who was putting out one of these forecasts, and gave Trump a 25% chance of winning. And so when Trump won, the press crucified Nate Silver and said, "Oh, your models are wrong." Blah, blah, blah. But remember, 25% is not zero. So the question is, did we get unlucky or lucky, depending on your political persuasion? Did we get unlucky, or was the model wrong? That's another great question that I don't know how to answer. And it's one thing that's kind of been percolating in the back of my mind that I'd love to know. Sorry, you're asking all tough questions. As a general rule, I usually don't answer tough questions, and this is why.
Yeah. Thank you.
Yeah, so maybe Daniel, we'll leave it at that, but I just want to thank you for that presentation. I think you've left everybody with plenty of food for thought and plenty of ideas and things, and the references to your book and your website. It was good to see them there, but really thank you so much. It was great.
As I said before, the pleasure is certainly mine. I want to say, number one, thank you so much to Dee for the initial invitation. Thank you for your persistence in trying to track me down. So truly honored to be a part of this meetup. Thanks to Vince too for the introduction and to helping organize this. But most importantly, thanks to all of you for taking time out of your busy day to come talk about, you know, metrics and forecasting and that kind of boring stuff. So so glad to be here. I hope I get a chance to come back and see you all in the future. Maybe, fingers crossed, if we can get through lockdowns and all this stuff, maybe even in person at some point. That would be great.
Great.
So
Thank you.
yeah, please
Okay.
everybody, yeah, be
Thank
safe,
you.
be well, and we'll see you
All the
soon. Thank
best.
you very much.
Thanks, Dan.
Bye.
Thanks.
Bye-bye.
Thanks.
Thanks. Bye.